On November 14, 2023, Voyager 1 suddenly went silent. It had already traveled beyond our solar system and was now only sending useless binary data. It seemed like this spacecraft was lost forever. The culprit turned out to be corrupted memory in its flight data system, or FDS. There was a risk of permanent communication loss, but the team of scientists refused to give up. They made a bold decision to relocate the corrupted code to another section of the probe's memory. This work began on April 18, 2024, and carried enormous risk. It takes 20.5 hours for a signal to reach Voyager and the same amount of time for a response to return. Every attempt was like a step into the unknown. And then, just 2 days later, after months of hard work and waiting, something amazing happened. Voyager 1 reestablished contact. So what unique discoveries did Voyager make at the edge of the solar system? Why wasn't that place what scientists expected it to be? And what was so unusual about the mysterious signal Voyager 1 sent after months of silence? In the late 1970s, a rare event occurred in our solar system. There was a planetary alignment that happens only once every 175 years. At that moment, all the large gas giants lined up on one side of the solar system. This provided a unique opportunity to study them in a single mission, and NASA took full advantage of this chance. It was a cosmic window that had opened, offering humanity an unprecedented opportunity to explore the outer reaches of our planetary neighborhood in ways that had never been possible before and might not be possible again for nearly 2 centuries. The planning for this mission had actually begun years earlier. When scientists and engineers realized that this rare alignment was approaching, teams of brilliant minds worked tirelessly to design spacecraft that could withstand the harsh conditions of deep space for what they hoped would be at least a 4-year mission. Little did they know that these mechanical explorers would continue functioning and sending back valuable data for nearly half a century, far exceeding anyone's wildest expectations. Voyager 1 was launched after its twin, Voyager 2, but due to a faster trajectory, it moved ahead. Its speed was 38,000 kilometers per hour, a velocity that seems almost incomprehensible when you consider that it's faster than any human has ever traveled. Just 13 days after launch, it captured a historic photograph of Earth and the Moon from a distance of 7.2 million miles, marking the beginning of their remarkable journey. This image was more than just a photograph. It was a testament to human ingenuity and our ability to extend our reach far beyond our planetary home. The twin Voyagers were marvels of engineering, packed with cutting-edge technology of their era. Each spacecraft carried a suite of scientific instruments designed to study magnetic fields, charged particles, plasma waves, and cosmic rays. They had cameras to capture images of planets and their moons, spectrometers to analyze atmospheric composition, and radiometers to measure temperatures. Every component had been carefully selected and tested to ensure it could survive the journey through the harsh environment of space. In 1979, both spacecraft reached Jupiter, the giant of our solar system. What they discovered there exceeded all expectations. They found unknown rings encircling the massive planet, delicate structures that had gone undetected by Earth-based telescopes. They discovered 3 new moons, adding to the known family of Jovian satellites. The clear images they captured of Jupiter's largest satellites were revolutionary, providing scientists with their first detailed look at these distant worlds. The Voyagers confirmed that Ganymede, not Titan as previously thought, is the solar system's largest moon. Ganymede turned out to be even larger than the planet Mercury, a fact that reshaped our understanding of the relative sizes of objects in our solar system. The spacecraft also found that Europa's surface is covered with smooth, cracked ice, like a frozen ocean with fractures running across its surface. This data supported the theory of a subsurface ocean, leading to exciting speculation about the possibility of life existing beneath Europa's icy shell. The discovery of Europa's potential subsurface ocean was particularly thrilling, because liquid water is considered essential for life as we know it. Scientists began to theorize that beneath the moon's frozen exterior, there might be warm water heated by tidal forces from Jupiter's immense gravitational pull. This heat could create conditions similar to the deep ocean vents on Earth, where life thrives in complete darkness, deriving energy from chemical processes rather than sunlight. Additionally, scientists observed Jupiter's Great Red Spot up close for the first time. This centuries-old storm is larger than our entire Earth, a swirling maelstrom of gases that has been raging for at least 350 years and possibly much longer. The Voyagers revealed that this massive anticyclonic storm rotates counterclockwise and contains winds exceeding 400 kilometers per hour. The detailed images and data allowed scientists to study the storm's structure, composition, and dynamics in ways that had never been possible before. The spacecraft also discovered that Jupiter has a faint ring system, something that had not been detected from Earth. These rings are composed primarily of dust particles, kicked up from some of Jupiter's smallest moons by micrometeorite impacts. Unlike Saturn's spectacular icy rings, Jupiter's rings are dark and difficult to see, which explained why they had remained hidden for so long. Jupiter was just the first stop on their magnificent journey, using its gravity to increase speed through a technique called gravitational assist, or gravity slingshot. Both spacecraft reached Saturn in 1980 and 1981. This gravitational assist is a brilliant application of celestial mechanics, where a spacecraft flies close to a planet and uses its gravitational field to alter the spacecraft's path and speed. The planet's orbital motion essentially gives the spacecraft a push, accelerating it toward its next destination without using any fuel. The encounter with Saturn was a major turning point in the Voyager mission. Initially, this was just a 4-year mission designed to study Jupiter and Saturn, but NASA had designed their trajectory so they could reach other planets too. If the spacecraft remained healthy and funding continued, this forward-thinking approach would pay enormous dividends. As the mission extended far beyond its original scope, a crucial decision was to pass close to Titan, Saturn's largest moon and the only moon in the solar system with a very thick atmosphere. Titan had long fascinated scientists because its atmosphere is denser than Earth's, and is composed primarily of nitrogen, like our own atmosphere, but with significant amounts of methane. This orange-colored world had been shrouded in mystery, its surface hidden beneath impenetrable haze. Ultimately, Voyager 1 was sent toward Titan for a close flyby. This decision meant that the spacecraft's trajectory would be deflected, sending it out of the plane of the solar system and preventing it from continuing on to Uranus and Neptune. It was a sacrifice made for science, trading the opportunity to visit more planets for a chance to study this unique moon in detail. Meanwhile, Voyager 2 was directed toward Uranus and Neptune, ensuring that humanity would still get to visit all the outer planets. These spacecraft sent incredibly clear images of Saturn and its magnificent rings, revealing that they consist of hundreds of thin, unique ringlets rather than solid structures. The rings turned out to be far more complex than anyone had imagined, with intricate patterns, waves, and gaps created by the gravitational influence of Saturn's many moons. Some moons, called shepherd moons, actually keep certain rings in place through their gravitational pull, preventing the ring particles from drifting away. For new moons were discovered during the Voyager encounters with Saturn, with Mama's being particularly notable. This small moon was heavily cratered, bearing the scars of countless impacts over billions of years. The largest of these craters, named Herschel Crater, was so massive that it gave Mama's an uncanny resemblance to the Death Star from Star Wars. The impact that created this crater must have nearly destroyed the moon entirely, and scientists marveled that Mama's had survived such a catastrophic collision. But there was disappointing news about Titan. Its atmosphere was so thick and hazy that the mysteries of its surface couldn't be revealed. Through visible light imaging, the cameras aboard Voyager 1 simply couldn't penetrate the dense orange smog that enveloped the moon. However, other instruments aboard the spacecraft were able to gather valuable data about Titan's atmosphere. Analysis showed that Titan's temperature was near methane's triple point, which is a unique condition where methane can exist as a solid, liquid, or gas, depending on slight changes in temperature and pressure. This was a groundbreaking discovery because it suggested that methane on Titan might behave similarly to how water behaves on Earth. Just as water on Earth can exist as ice, liquid water, and water vapor, methane on Titan could exist in all three states. This raised the tantalizing possibility that Titan might have methane rain, methane rivers, and methane lakes or seas. It would take future missions, particularly the Cassini-Huygens mission, to confirm these predictions and reveal that Titan does indeed have liquid methane lakes and seas on its surface, making it the only other world in our solar system known to have stable bodies of liquid on its surface. After Saturn, the paths of both spacecraft separated forever. Saturn's gravity dramatically increased Voyager 1's speed, making it the fastest spacecraft in history at that time, traveling at a velocity that would allow it to escape the solar system entirely. Meanwhile, Voyager continued on its planetary tour toward Uranus, taking advantage of the rare planetary alignment that made this extended mission possible. Voyager reached Uranus in January 1986, passing within 50,600 miles of its surface. This encounter occurred during a particularly significant time in NASA's history, coming just days after the tragic Challenger disaster that claimed the lives of 7 astronauts. In some ways, Voyager 2's successful flyby of Uranus provided a much-needed reminder of NASA's achievements and capabilities during a period of national mourning. Scientists were astonished to find that Uranus was very different from Jupiter and Saturn. While gas giants like Jupiter and Saturn are composed of approximately 90% hydrogen and helium, Uranus has these gases only in its atmosphere. Below the atmospheric layer lies a vast ocean of water, ammonia, methane, and hydrogen sulfide, with a core of rock and ice at its center. This internal structure is fundamentally different from that of Jupiter and Saturn, leading scientists to realize that not all giant planets are alike. Later, planets with this internal structure were named ice giants, to distinguish them from the gas giants Jupiter and Saturn. This classification helps scientists better understand planetary formation and evolution. Uranus also turned out to be the coldest planet in the solar system, with atmospheric temperatures dropping as low as -124 degrees Celsius, even colder than Neptune despite being closer to the Sun. This unexpected finding puzzled scientists and suggested that Uranus has some unique characteristics that prevent it from generating or retaining as much internal heat as Neptune. One of the most unusual features of Uranus is its extreme axial tilt. The planet is essentially tipped over on its side, with its rotational axis tilted 98 degrees from perpendicular to its orbital plane. This means that Uranus essentially rolls around the Sun on its side, leading to extreme seasonal variations. During Uranus's 84-year orbit around the Sun, each pole experiences 42 years of continuous sunlight, followed by 42 years of complete darkness. No one knows for certain what caused this extreme tilt, but the leading theory suggests that Uranus suffered one or more massive collisions with Earth-sized objects early in the solar system's history. Voyager also discovered 10 new moons orbiting Uranus and found that the planet has a complex ring system. These rings are dark and narrow, very different from Saturn's bright, wide rings. The Uranian rings are composed of dark material, possibly carbonaceous particles, giving them a coal-black appearance that makes them difficult to detect. The spacecraft also studied Uranus's 5 major moons in detail, finding that they have diverse surfaces showing evidence of past geological activity. After collecting data from Uranus, Voyager headed toward its final target, Neptune. It reached Neptune in August 1989 and remains the only spacecraft to have visited the solar system's 8th and most distant planet. The journey from Uranus to Neptune took 3.5 years, during which the spacecraft traveled through the cold, empty reaches of the outer solar system, alone and vulnerable, yet continuing to function perfectly. On August 25, 1989, Voyager captured the first clear images of Neptune, completing its grand tour of the outer planets. The planet appeared bright blue in the images, a color caused by methane in its atmosphere that absorbs red light and reflects blue light back into space. Although later reprocessing of the data revealed that Neptune's true color is more aqua-green, similar to Uranus. The initial images of a brilliantly blue Neptune captured the public's imagination. Neptune turned out to be a surprisingly active world despite being so far from the Sun that it receives only about 1,000th the sunlight that Earth does. The planet has the strongest winds in the solar system, with wind speeds exceeding 1,000 kilometers per hour. These supersonic winds create dynamic weather systems, including a great dark spot similar to Jupiter's Great Red Spot, though Neptune's spot proved to be temporary and had disappeared by the time the Hubble Space Telescope observed Neptune a few years later. Voyager discovered 6 new moons orbiting Neptune and found that the planet has a ring system similar to those of the other giant planets. One of Neptune's moons, Triton, proved to be particularly fascinating. Triton is the 7th largest moon in the solar system and is unique in being the only large moon that orbits in the opposite direction to its planet's rotation. This retrograde orbit suggests that Triton didn't form alongside Neptune, but was instead captured by the planet's gravity, possibly from the Kuiper Belt. Despite being one of the coldest objects in the solar system, with surface temperatures around -235 degrees Celsius, Triton showed evidence of recent geological activity. Voyager detected active geysers on Triton's surface, plumes of nitrogen gas and dark material shooting up to heights of 8 kilometers, before being blown by winds across the moon's surface. This discovery made Triton one of the few geologically active worlds in the solar system, despite its extreme cold and distance from the sun. Asterisk. While Voyager was exploring Uranus and Neptune, Voyager 1 could only continue its journey outward, having completed its planetary encounters at Saturn. After the Saturn mission, engineers had shut down most of its imaging instruments to conserve power, keeping active only the technology that could study the surrounding environment and the particles and fields in space. Asterisk. But Voyager 1 got another chance to make history. On February 14, 1990, from a distance of 3.7 billion miles, it captured an image of Earth where our planet appeared as just a pale blue dot, measuring 0.12 pixels. This memorable photograph, known as the pale blue dot, was the last image taken by Voyager 1. The image was taken at the request of astronomer Carl Sagan, who had been a member of the Voyager imaging team and wanted one last look back at our home planet from the edge of the solar system. Asterisk. In Sagan's famous reflection on this image, he wrote, "Look again at that dot. That's here. That's home. That's us. On it everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering. Thousands of confident religions, ideologies, and economic doctrines. Every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust, suspended in a sunbeam." Asterisk. This pale blue dot image became one of the most iconic photographs in the history of space exploration, serving as a powerful reminder of our place in the universe and the fragility of our world. After capturing this image and a few others showing the planets of our solar system from this unique vantage point, the imaging systems on both Voyagers were permanently shut down to conserve power for the instruments that would continue studying interstellar space. Asterisk. Following this, our space travelers entered a long period of relative quiet that lasted about a decade and a half. During this time, they continued to travel outward, moving beyond the realm of the planets and into the vast, empty space between our solar system and the nearest stars. The spacecraft continued to send back data, but there were no more planetary flybys to capture public attention, and the mission faded somewhat from public consciousness, even as it continued to produce valuable scientific results. Asterisk. But then an extraordinary event occurred that thrust the Voyager mission back into the spotlight. On August 25, 2012, Voyager 1's instruments recorded a sharp drop in charged particles coming from the sun, known as solar wind particles, and simultaneously detected an increase in cosmic rays, high-energy particles that originate from outside our solar system, traveling through interstellar space. This data indicated something momentous. The spacecraft had finally reached interstellar space, the region where the sun's influence ends and the space between the stars begins. This was a historic milestone. Voyager 1 had become the first human-made object to leave the heliosphere and enter interstellar space, the slower-moving Voyager to cross the same boundary in November 2018, making it the second human-made object to enter interstellar space. These crossings represented humanity's first physical presence in the space between the stars, a realm that had been completely unexplored by direct measurement until the Voyagers arrived. The unique bubble of our solar system, called the heliosphere, extends approximately 11 billion miles from the sun, though its size and shape vary over time in response to changes in solar activity. The heliosphere is formed by the solar wind, a stream of charged particles, primarily protons and electrons, emanating from the sun at speeds of about 400 kilometers per second. This solar wind creates a bubble around the solar system, pushing against the interstellar medium and creating a protective shield that deflects most of the high-energy cosmic rays that would otherwise penetrate into the inner solar system. The heliosphere ends at the heliopause, the boundary between the heliosphere and the interstellar medium. At this boundary, the solar wind slows dramatically and turns to flow along the heliopause rather than continuing outward. Meanwhile, The interstellar medium, which consists of gas and dust between the stars, flows past the heliosphere in the opposite direction as the solar system moves through the galaxy. The Voyagers are the only spacecraft to have crossed this boundary and ventured beyond our solar system into interstellar space. What they discovered there sparked considerable interest and debate among scientists, as the boundary region turned out to be more complex and dynamic than anyone had anticipated. It was previously believed that the solar wind gradually weakens as it moves away from the sun, slowly fading out over a large transition region. But data from the spacecraft revealed that the solar wind doesn't fade gradually, but reaches a relatively sharp boundary. Beyond this boundary, its influence ends quite abruptly and interstellar space begins. This means the solar wind doesn't just disappear, but changes direction dramatically, flowing along the heliopause and creating a physical boundary between the two environments. The solar wind flows around the heliopause in one direction, while interstellar plasma flows past from outside in the other direction. Scientists were able to determine the shape of the heliosphere using data from the Voyagers and other spacecraft. On one side, the side facing the direction of the solar system's motion through the galaxy, the heliosphere is somewhat sphere-like and compressed by the interstellar medium, pushing against it. On the other side, the trailing side, the heliosphere is stretched into a long tail, like a comet's tail, extending far behind the solar system as it moves through space. Surprisingly, this shape isn't stable. The boundary of the solar system is constantly moving and fluctuating in response to variations in both the solar wind and the interstellar medium. Large waves form on the surface of the heliosphere, ripples and undulations that can extend up to 10 astronomical units, which is 10 times the distance between Earth and the Sun, approximately 930 million miles. These waves are caused by variations in the solar wind strength as the Sun goes through its 11-year activity cycle, and by disturbances in the interstellar medium as the solar system encounters denser or less dense regions of space. Additionally, by studying Voyager data, scientists found that the heliopause changed very rapidly in a short time, much faster than theoretical models had predicted. This might explain why both spacecraft took such a long time, a full 6 years, to cross from one side of the boundary region to the other. Voyager 1 crossed into interstellar space in 2012, while Voyager 2 didn't cross until 2018, despite being only a relatively short distance behind. During those 6 years, the heliopause itself moved outward and inward multiple times in response to changes in solar activity and the interstellar environment. However, these rapid changes in the heliopause's dynamics don't match current scientific models very well, and many aspects of this boundary region remain mysterious and poorly understood. Scientists continue to analyze the data, trying to understand what causes these rapid fluctuations and what they tell us about the interaction between the solar wind and the interstellar medium. Similarly, the temperature and density of the solar wind near the heliopause are beyond what current models predicted. Astrophysicists expected a sharp increase in both temperature and density as solar particles slow down due to pressure from the interstellar medium, converting their kinetic energy into heat. This increase did occur, but the measured values were about 10 times lower than theoretical predictions suggested they should be. Where does this missing energy go? This question remains unanswered and is one of the many mysteries that the Voyager mission has revealed. Data from Voyager 1 and Voyager 2 also revealed that interstellar space contains denser and cooler plasma than the region near the solar system's boundary. The plasma near the heliopause is hotter and less dense, which makes sense because it consists of solar wind particles that have been heated. As they slow down, importantly, these two types of plasma interact with each other at the boundary. Particles from the solar wind and interstellar wind mix together, creating a turbulent boundary layer on one side of the heliopause. But the interaction between the Sun and interstellar space doesn't end at the heliopause. The Voyager discovered that shock waves emanating from the Sun can cross the heliopause and propagate into interstellar space. These shock waves are caused by coronal mass ejections, massive eruptions of plasma from the Sun's outer atmosphere that travel through space at high speeds. When these solar shock waves reach the heliopause, they can push through and create disturbances in the interstellar medium, similar to those created by supernovae, which are exploding stars that send shock waves racing through interstellar space. Thanks to the Voyagers, scientists also discovered that the interstellar magnetic field is 2 to 3 times more powerful than previously thought. This stronger magnetic field means that interstellar particles exert about 10 times more pressure on the heliosphere than scientists had expected. This finding has important implications for understanding how the heliosphere protects the solar system from cosmic rays and how the sun's protective bubble might vary in strength depending on where in the galaxy the solar system is located. Data from this interaction between the solar, wind, and the interstellar medium helps explain what happens at the boundary between stellar systems and the space between them. This information can be applied to understanding other stars that scientists are studying, because it's believed that other stellar systems have similar structures to our solar system. Most, if not all, stars likely have their own heliospheres, bubbles of stellar wind that push against the interstellar medium. And studying our own heliosphere in detail helps us understand what those distant stellar systems might be like. Throughout their entire journey through interstellar space, the Voyagers have continued sending signals to Earth, providing data about their instruments' condition, their location, and the environment they're passing through. However, in 2022, Voyager 1 sent a strange signal from 14.6 billion miles away that puzzled scientists. The spacecraft began sending jumbled data about its position, transmitting sequences that didn't make sense, like strings of zeros or the number 377 repeated over and over. This mysterious signal initially worried scientists. These numerical sequences could represent important information that was being corrupted in transmission, or they could indicate that the spacecraft systems were failing after so many years in space. The garbled data seemed to be coming from the spacecraft's attitude control system, which keeps Voyager oriented correctly so that its antenna points toward Earth. It turned out to be a malfunction, though not a catastrophic one. The problem was related to the spacecraft's attitude control and maneuvering system, one of the onboard computers that controls the spacecraft's orientation in space. This computer had somehow started sending its telemetry data through a different computer that wasn't functioning correctly, resulting in the garbled signals. While manual control of the spacecraft was still possible, and the spacecraft's orientation hadn't actually changed, Voyager 1 couldn't accurately report its precise position because the attitude data was corrupted. Cosmic radiation had likely affected the spacecraft's systems, causing this computer error. After traveling through space for more than 4 decades, passing through regions of high radiation near Jupiter and Saturn and being constantly bombarded by cosmic rays, it's actually remarkable that such problems don't occur more frequently. NASA engineers successfully solved this problem by sending commands to reroute the telemetry through another onboard computer, bypassing the malfunctioning system and restoring normal data transmission. Another concerning event occurred when Voyager 1 went silent for 5 months starting on November 14, 2023. This prolonged silence was more worrying than the previous glitch because the spacecraft stopped sending usable data entirely. Investigation revealed that the problem was caused by corrupted code on one of the spacecraft's memory chips, specifically in the Flight Data System, or FDS, which is responsible for packaging science and engineering data before sending it to Earth. To fix this problem, the team made a bold and risky decision. They would relocate the corrupted code to another section of the onboard computer's memory, essentially reprogramming part of the spacecraft from 15 billion miles away. This operation began on April 18, 2024, and required extreme care and patience. The data transfer process would take considerable time, and there was no guarantee it would work. After sending a signal with the new instructions, the team had to wait 20.5 hours for it to reach the spacecraft, traveling at the speed of light across the vast distance between Earth and Voyager. Then they had to wait another 20.5 hours for a response to travel back, a total of 45 hours before they would know if their commands had been received and executed successfully. Each command sequence had to be carefully planned and tested on ground replicas of the Voyager computers to ensure it would work correctly. By April 20th, just 2 days after starting the operation, the team confirmed the operation's success. After 5 long months of silence, scientists had managed to restore communication with Voyager 1. The spacecraft was back online, sending clear data once again. It was a remarkable achievement, a testament to the skill and dedication of the engineering team, and to the robust design of the spacecraft that allowed such complex operations to be performed. After more than 45 years in space, these periods of silence and technical problems remind us that the lives of our space travelers are now nearing their end. The spacecraft were designed to last 4 years, maybe 5 if they were lucky. No one expected them to function for nearly half a century. But now, after more than 45 years of continuous operation, their power is finally running low, and their systems are beginning to fail more frequently. NASA expects Voyager 1's instruments to function until around 2025, after which they will gradually be shut down to conserve the dwindling power supply. Voyager 2 might last a bit longer, perhaps until 2026 or 2027. The spacecraft are powered by radioisotope thermoelectric generators, devices that convert heat from decaying plutonium into electricity. But the plutonium is slowly running out, and the power output decreases by about 4 watts per year. Eventually, there won't be enough power to operate even the most essential systems, in a few years. The spacecraft will run out of the energy needed to communicate with Earth. Perhaps around the mission's 50th anniversary in 2027, this will be the project's final chapter. Engineers will send final commands to shut down the last remaining instruments and transmitters. After that, the Voyagers will go silent, continuing their journey through the void, but no longer able to tell us what they're experiencing. Even after contact is lost, these space travelers' journey will continue. They may see many interesting things in the millennia and millions of years to come. Though they won't be able to tell us about them anymore, they will become silent ambassadors, carrying their golden records with messages from Earth, continuing outward into the galaxy long after the civilization that built them has passed into history. Voyager 1 is moving away at approximately 3.5 astronomical units per year. 1 astronomical unit is the average distance between the Sun and Earth, about 93 million miles or 150 million kilometers. At this speed, Voyager 1 is currently heading toward the constellation Ophiuchus. In about 38,200 years from now, it will pass within 1.7 light-years of a small star called Gliese 445, also known as AC plus 793,888. In the constellation Ursa Minor, this close approach, though still more than 10 trillion miles away from the star, will be the closest Voyager 1 comes to another stellar system for many millennia. Its twin, Voyager 2, is moving away from the solar system at approximately 3.1 astronomical units per year, a bit slower than its sibling. In about 40,000 years, it will pass within 1.7 light-years of a star named Ross 148 in the constellation Andromeda. Like Voyager 1's closest approach, this will be a distant flyby, nowhere near close enough to enter that star's planetary system if it has one. Currently, as of early 2025, Voyager 1 is approximately 15.5 billion miles from Earth, while Voyager 2 is about 12.9 billion miles away. Both spacecraft are now in interstellar space, having crossed the heliopause years ago. However, it wouldn't be entirely accurate to say the Voyagers have completely left the solar system, depending on how you define the solar system's boundaries. Scientists believe the solar system includes everything under the Sun's gravitational influence, and that influence extends much farther than the heliopause. Today, most astronomers believe that the solar system's true outer boundary is the Oort cloud, a hypothetical spherical cloud of icy objects that surrounds the solar system. At an enormous distance, this cloud is the source of long-period comets, icy bodies that occasionally fall inward toward the Sun, creating the spectacular comets that grace our skies every few decades or centuries. The Oort cloud is thought to include distinct regions, a spherical outer Oort cloud and an inner disc-shaped region sometimes called the Hills cloud or inner Oort cloud. The estimated distance of the Oort cloud's inner edge from the Sun is about 2,000 to 5,000 astronomical units, while the outer edge might extend as far as 100,000 astronomical units, or even 200,000 astronomical units, which is roughly halfway to the nearest star, Proxima Centauri *. It will take Voyager 1 approximately 300 years to reach the inner edge of the Oort cloud, and possibly another 30,000 years to completely cross through it and emerge on the other side. Only then will the spacecraft have truly left the solar system behind, escaping the Sun's gravitational influence entirely. That crossing will be the final farewell to the solar system, though no one on Earth will know when it happens, since we will have lost contact with the spacecraft long before then. On their distant journey through the galaxy, these spacecraft encounter extraterrestrial life. They carry messages prepared by a team of scientists led by Carl Sagan and his colleagues. These messages are inscribed on golden phonographic records. one attached to each Voyager spacecraft. The records are made of gold-plated copper, chosen because gold doesn't corrode and should last for millions or even billions of years. In the vacuum of space, about 3/4 of the recording consists of music from various cultures and time periods around the world. The selection includes Bach, Mozart, Beethoven, and Stravinsky from the Western classical tradition, but also music from Indonesia, India, Japan, China, and Africa, plus blues, jazz, and rock and roll. Chuck Berry's Johnny B. Good represents rock and roll, while Louis Armstrong's jazz and traditional music from around the globe showcase the diversity of human musical expression. The disc contains greetings in 55 different languages, from ancient Sumerian and Akkadian to modern languages like English, Spanish, Mandarin, and Hindi. There are also spoken messages from then President Jimmy Carter and then UN Secretary General Kurt Waldheim. The Carter message reads, in part, "This is a present from a small, distant world. A token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so we may live into yours." Additionally, the record includes sounds of earth, thunder, wind, surf, birds, whales, and other animals, plus human sounds like footsteps, heartbeats, laughter, and a mother's first words to her newborn child. There are also 115 analog encoded images showing Earth's location in the galaxy, mathematical and physical constants, images of human anatomy and reproduction, pictures of human activities, and landscapes from around the world. The record jacket contains instructions for playing the record, including the stylus and cartridge, along with diagrams explaining how to decode the images and audio. The instructions are presented using scientific symbols that any advanced civilization should be able to understand, such as the hyperfine transition of hydrogen and binary numbers. There's plenty for aliens to discover if they ever find one of these spacecraft, but realistically, the chances of either Voyager being found are astronomically small. Space is unimaginably vast, and the Voyagers are tiny objects traveling through an essentially infinite void. Even if there are thousands or millions of intelligent civilizations in the galaxy, the odds of one of them happening upon a Voyager spacecraft are infinitesimally small. More likely, the Voyagers will continue floating peacefully through the cold, dark interstellar void for millions or billions of years, never encountering anything. They will remain symbols of humanity's quest for knowledge, silent monuments to our species' brief moment of technological civilization. They will continue reminding the universe, even if no one is there to notice, of the ambitions and hopes of inhabitants of a small, pale blue dot suspended in a sunbeam. The Voyager mission represents humanity at its best. Curious, ambitious, cooperative, and forward-thinking. The spacecraft were built during the Cold War, yet they carried messages of peace and hoped for contact with other civilizations. They were designed by teams of brilliant scientists and engineers working together toward a common goal. They were funded by a society willing to invest in pure science and exploration, seeking knowledge for its own sake rather than immediate practical benefit. The longevity of the Voyager spacecraft far exceeded anyone's expectations. They were designed to operate for 4 years, maybe 5 at most. No one imagined they would still be functioning and sending back data after 45 years. This remarkable longevity is a testament to the quality of their design and construction, but also to the dedication of the team that has kept them running. The Deep Space Network, NASA's collection of giant radio antennas located around the world, continues to track the Voyagers every day. Engineers send commands to shut down instruments as power becomes scarce, prioritizing the most important science instruments for as long as possible. They've developed techniques to squeeze every last bit of power from the decaying plutonium generators, implementing creative solutions that the original designers never anticipated would be necessary. The team managing the Voyagers today consists largely of engineers and scientists who weren't even born when the spacecraft launched. They've had to learn the intricacies of 1970s computer systems and programming languages that are now obsolete. The original documentation, stored on aging paper and outdated digital formats, has had to be carefully preserved and sometimes recreated from memory by the few remaining members of the original team who are still alive and able to consult. In 1977, when Voyager 1 and Voyager 2 were launched from Cape Canaveral less than a month apart, the world was a very different place. The Cold War was at its height. Personal computers didn't exist. The internet was years away from being invented, and the idea of carrying a powerful computer in your pocket that could access all human knowledge would have seemed like pure science fiction. Yet the Voyagers, built with the technology of that era, continue to function and produce valuable scientific data today. Actually, Voyager to launch first on August 20th, 1977, followed by Voyager 1 on September 5th, 1977. The reason for the seemingly backward naming is that Voyager 1 was on a faster trajectory that would get it to Jupiter and Saturn sooner than its twin, so it was designated as the first spacecraft even though it launched second. Due to its different flight path, Voyager to reach the edge of our solar system 6 years after its companion, but it had the privilege of visiting Uranus and Neptune, making it the only spacecraft to complete a grand tour of all four giant planets. Both devices observed something very strange as they traveled outward. As you move away from the sun, the density of space doesn't continuously decrease as you might expect, but actually increases at certain points. Interstellar space is commonly considered a vacuum, and it is indeed far emptier than anything we can create on Earth. But this isn't entirely accurate to call it empty. Matter exists there, just at extraordinarily low densities. In the solar system, the average density of protons and electrons in the solar wind ranges from 3 to 10 particles per cubic centimeter near Earth's orbit. For comparison, the air you're breathing right now contains about 25 quintillion molecules per cubic centimeter. So even the densest parts of the solar wind are far more empty than the best laboratory vacuum we can create on Earth. But as you travel farther from the sun, this density decreases. The solar wind spreads out as it moves away from its source, and the particles become more and more spread out. The lowest space density occurs at the edge of the solar system, at the heliopause. Here, the speed of the solar wind, that stream of charged particles emanating from the sun, or in other words, solar plasma, drops to essentially zero. The region between the sun and the heliopause is called the heliosphere. It's a kind of bubble in which all planets of the solar system are immersed, a protective cocoon that shields us from the harsh environment of interstellar space. At the heliopause boundary, the density of protons and electrons drops to about 0.0 particles per cubic centimeter, the lowest density anywhere in the sun's domain. According to calculations behind the heliopause in interstellar space, the particle density should be about 0.037 particles per cubic centimeter, about 18 times denser than at the heliopause itself. Voyager 2's instruments confirmed that beyond the solar system, at a distance of 119.7 astronomical units, the density was indeed about 0.039 particles per cubic centimeter, which roughly matched calculations and confirmed scientists' theoretical models. But then strange things started happening that no one had predicted. At 124.2 astronomical units, or 18.5 billion kilometers from the sun, the density had increased to about 0.1 particles per cubic centimeter, nearly 3 times higher than expected. Why is this density increasing beyond what models predicted? Why isn't interstellar space uniform in density? These questions puzzled scientists and revealed that our understanding of the interstellar medium was incomplete. We'll discuss the reasons for these density variations further. But for now, let's talk about another bubble, one that's much larger than the heliosphere, so you can understand how thoughtfully the universe has placed us inside not one, but two protective bubbles. When you look at deep space images taken by powerful telescopes, space appears filled with clouds of interstellar dust and glowing gas. Colorful nebulae where stars are born. Dark molecular clouds where the material is so dense that it blocks light from stars behind it. But already in the 1970s and 1980s, scientists began noticing that the space around the sun differs from this picture. It appears as if the solar system is suspended in an almost completely empty place, a region largely devoid of the gas and dust that fills much of the galaxy. This year, scientists from the Harvard Smithsonian Center for Astrophysics, known as CFA, proved conclusively that yes, we really are in a kind of empty space, a cavity in the interstellar medium. They conducted very complex computer simulations that created a three-dimensional model of space and time in our region of the galaxy, tracking the movements of stars and gas over millions of years. The study revealed that the Sun and Earth are near the center of a very large bubble, with a diameter of about 1,000 light-years. They named it the local bubble, according to their calculations. This bubble began forming about 14 million years ago. long before humans or even most modern mammals evolved on Earth, for this bubble to form. Approximately 15 to 20 supernovae had to explode over a period of several million years. In the same general region of space, these catastrophic stellar explosions, each releasing more energy than the Sun will emit in its entire 10 billion-year lifetime, pushed interstellar gas outward in all directions, creating a bubble-like structure with a very dense shell and an evacuated interior. The shells of these supernova remnants eventually merged together, creating one large expanded bubble. Today, the surface of this bubble is very dense, containing most of the gas that was pushed outward by the explosions, while the interior remains relatively empty. And remarkably, this bubble is still growing in size, still expanding outward as the momentum from those ancient explosions continues to push material away from the center. Asterisk, when this bubble first formed, it was expanding at about 60 miles per second, or roughly 100 kilometers per second, an enormous velocity driven by the energy of multiple supernovae. According to data from the European Space Agency's Gaia Space Observatory, which has precisely measured the positions and motions of more than 1 billion stars, this bubble is currently expanding at about 4 miles per second, or roughly 6.7 kilometers per second, much slower than initially, but still considerable. Asterisk, on the bubble's surface, 7 star-forming regions were identified, places where the dense shell of gas has collapsed under its own gravity and begun forming new stars. Star formation occurs all around the surface of the local bubble, wherever the shell has become dense enough to collapse, and there are many such bubbles throughout the galaxy, carved out by supernovae and stellar winds from massive stars. Asterisk, therefore, it's possible that other stars exist, perhaps with planets and even life, that are in their own local bubbles just like us. The galaxy might be full of these bubbles, interconnected cavities in the interstellar medium, like the holes in Swiss cheese, with new stars forming at the boundaries where bubbles collide and compress the gas. Asterisk, interestingly, the Sun wasn't initially at the center of this bubble. When these catastrophic explosions occurred, the Sun was very far from the event site, about 1,000 light-years away, perhaps on the other side of the bubble, or even outside it completely. But as explained by astrophysicists from the University of Vienna and other institutions, about 5 million years ago, while orbiting the galactic center as all stars do, the Sun's path happened to take it nearly to the center of this bubble. Asterisk. This timing is fascinating when you consider that 5 million years ago is also roughly when the human lineage diverged from our closest ape relatives. Our ancestors evolved during the time when the Sun was entering this protective bubble, and all of recorded human history has occurred while we've been safely inside it. Asterisk, this finding aligns with other studies that have detected deposits of radioactive iron isotopes in Earth's layers, isotopes that could only have come from nearby supernovae. By analyzing sediment cores from the ocean floor and ice cores from Antarctica, scientists have found evidence of supernova explosions occurring relatively close to Earth at various times in the past few million years, consistent with the formation of the local bubble. Asterisk, researchers believe there are probably many other star-forming bubbles throughout the Milky Way galaxy. Research author Alyssa Goodman from Harvard explains that statistically, the Sun wouldn't be in the middle of a giant bubble if these bubbles weren't spread everywhere throughout the galaxy. The local bubble is exactly the bubble we're in now, but it's likely just one of hundreds or thousands of similar structures. Asterisk. She said that research suggests that the Sun has probably passed through several super bubbles in its history as it orbits the galactic center. Over the Sun's 4.6 billion-year lifetime, it has completed about 20 orbits around the Milky Way, and during those orbits, it has passed through spiral arms, molecular clouds, and various types of bubbles and cavities in the interstellar medium. Asterisk, scientists have compared the structure of the galaxy to Swiss cheese, where the holes are formed by supernova explosion and the intense stellar winds from massive stars. The shells of these holes, where the gas is compressed, become sites of new star formation. The research team plans to map even more cosmic bubbles to get a complete three-dimensional model of their shape, location, and size throughout our region of the galaxy and eventually beyond. Asterisk, by discovering where these bubbles are and how they're distributed, scientists can understand how they function as nurseries for stars, how they interact with each other, and how galaxies like the Milky Way have evolved over billions of years. The bubbles aren't static structures, but dynamic, evolving systems that change the distribution of gas in the galaxy and influence where and when new stars can form. Asterisk with the revelation of the local bubble. The structure of our cosmic neighborhood looks something like this. At the very center is the Sun, around which 8 planets orbit in the planetary system we're most familiar with. The last planet, Neptune, orbits at a distance of approximately 4.5 billion kilometers or 30 astronomical units from the Sun. Beyond Neptune lies the Kuiper Belt, a disc-shaped region containing numerous small icy bodies. Asterisk, the Kuiper Belt is a group of small astronomical objects, the most famous being Pluto, which was long considered the 9th planet before being reclassified as a dwarf planet in 2006. The Kuiper Belt extends from about 30 to 55 astronomical units from the Sun, and it's believed to contain hundreds of thousands of icy bodies larger than 100 kilometers across, plus countless smaller ones. Asterisk further ahead, at 125 to 135 astronomical units depending on solar activity and other factors, is the heliopause, which we've already discussed extensively. This is where the solar wind stops and interstellar space begins. Now let's explain why density starts increasing at this boundary and continues to increase beyond it. Asterisk, this happens because solar plasma collides with interstellar plasma at the heliopause. Imagine the streams of particles flowing toward each other at cosmic velocities, each traveling at hundreds of kilometers per second. Obviously, density increases at the collision point where these two flows meet and interact. It's like a traffic jam, but instead of cars, it's a chaos of subatomic particles, protons and electrons colliding, mixing, and creating turbulence. Asterisk, behind this jam, at a distance of 0.75 to 1.5 light years from the Sun, extends the Oort cloud, a hypothetical spherical cloud of icy bodies. This is believed to be the source of long-period comets, those visitors from the deep freeze that occasionally fall inward toward the Sun, taking thousands or even millions of years to complete one orbit. Here, at this enormous distance, the interstellar environment dominates. The Sun's light is so faint that it provides almost no heat, and temperatures are only a few degrees above absolute zero. Asterisk, but the Sun still maintains its gravitational hold on these distant objects with its last strength. The Oort cloud represents the absolute frontier of the Sun's gravitational influence, the final outpost of the solar system before the vast emptiness between stars truly begins. Asterisk, now many of you might ask, okay, we're in a bubble, actually a double bubble with the heliosphere inside the local bubble. So how does this affect our lives? What practical difference does it make that we're inside these protective structures? Asterisk, about the smaller bubble, the heliosphere. We can clearly say that thanks to it, thanks to the traffic jam formed at its boundary, Earth is largely protected from high-energy cosmic particles coming from the galactic center and from supernovae explosions throughout the galaxy. Without this protection, Earth would be bombarded by far more cosmic radiation than it currently receives. Asterisk, this additional radiation would have several effects. It would increase mutation rates in living organisms, potentially making it harder for complex life to evolve and survive. It would also make space travel more dangerous, as astronauts would be exposed to much higher radiation doses. The heliosphere thus serves as a protective shield, deflecting or slowing down most of the galactic cosmic rays that would otherwise reach Earth. Asterisk. Now let's talk about the local bubble and its significance for life on Earth, and our ability to observe the universe. Scientists have long known that our galaxy, the Milky Way, is shaped like a spiral disk about 100,000 light-years across, but only about 1,000 light-years thick in most places. Several spiral arms emerge from the central bulge, which scientists call arms because they extend from the galaxy's center like arms reaching out. Asterisk, currently, our Sun is located roughly midway between the major spiral arms, the Sagittarius arm, and the Perseus arm. In a smaller spur called the Orion spur or local spur, our Sun orbits the galactic center, taking about 200 million years to complete one orbit. We call this one galactic year. Since humanity appeared on Earth, only about 0.001 of this galactic year has passed. A mere blinking cosmic time, asterisk on its path through the galaxy, the Sun, along with all its planets, passes not only through bubbles like the local bubble, but also through denser accumulations of interstellar gas, particularly when crossing spiral arms. In these spiral arms, where space matter density increases hundreds or even thousands of times compared to the local bubble, Conditions are very different and potentially more hazardous for life, astrophysicist Marov, Offer from Boston University, and other researchers have used the latest Milky Way models to investigate what happened on Earth when the Sun was crossing galactic arms during its long journey around the galaxy. These arms have very high interstellar space density because they're regions where gas accumulates and stars form in great numbers. A fascinating correlation was found between the times when the Sun crossed spiral arms and 5 known mass extinction events in Earth's history. These catastrophic events, with large percentages of species died out relatively suddenly, occurred approximately 415, 322, 300, 145, and 33 million years ago. Each of these dates corresponds roughly to times when the Sun would have been passing through or near a spiral arm. The connection isn't definitively proven, and there are certainly other factors that contributed to these extinction events, such as volcanic eruptions, asteroid impacts, and climate changes. But the correlation is intriguing and suggests that our location in the galaxy might play a role in the history of life on Earth. When passing through spiral arms, Earth would be exposed to more supernovae explosions occurring nearby, more cosmic radiation, and possibly more comet impacts as the denser environment perturbs the Oort cloud. So we can assume that currently, the Sun is in a calm harbor, a relatively safe region of the galaxy, which is good for all living things on Earth. And we can say that humanity is very fortunate to have evolved and built civilization during a time when the Sun is in the local bubble, protected from many of the hazards that might exist in denser regions of the galaxy. Or perhaps these two events are somehow connected: humanity's appearance and the Sun being in a safe location. Could the calm environment of the local bubble have been necessary for intelligent life to evolve? Science doesn't have enough information to answer this question definitively, at least not yet. But it's certainly an intriguing possibility that makes you wonder about the cosmic conditions necessary for intelligence to emerge. What we can definitely say is that we see such a colorful, star-filled sky above our heads only because we're in an almost completely empty space, the local bubble. If the space around us were much denser, filled with dust and gas like many regions of the galaxy, many stars wouldn't be visible to us. The dust would absorb and scatter their light, creating a murky, hazy sky where only the nearest and brightest stars could be seen. And who knows, if we were truly in darkness, unable to see the stars and contemplate the cosmos, would we have developed astronomy and science as we did? Our ability to see thousands of stars with the naked eye and to observe distant galaxies with telescopes might be a direct consequence of living in this cleared-out bubble. We can say that the local bubble is like a gift to humanity that has now entered the space age, providing us with clear views of the universe and inspiration to explore it. For an interstellar craft traveling at very high speeds, one of the greatest dangers would be dust particles. Even tiny grains of dust, when struck at velocities of tens of thousands of kilometers per hour, would impact with enormous energy, potentially pulverizing a spacecraft or at minimum damaging critical systems. Even hypothetical concepts for future interstellar missions include massive frontal shields to protect against such impacts. But now it seems the universe itself has taken care of us by clearing out a bubble around the Sun. It has removed much of the dust from our local neighborhood, creating a relatively clear path for hundreds of light years in all directions. The universe is saying, as it were, go ahead, friends. The path to Alpha Centauri, Tau Ceti, and other nearby stars is relatively open. You have a head start, a cleared highway through the local interstellar medium. This cleared space won't last forever, though. Eventually, over millions of years, interstellar gas will flow back into the local bubble, filling it in. Or the Sun's motion through the galaxy will carry us out of the bubble into denser regions. But for now, for the brief span of human civilization, we find ourselves in an ideal location, protected, with clear views, and with relatively safe paths to nearby stars if we can develop the technology to reach them. Now, let's discuss another mystery the Voyagers have helped uncover: the strange sounds and signals from deep space. Space seems like a desolate, empty place where there's no trace of any other civilization. But does this mean the universe is completely silent and no one except us has tried to explore it? Scientists' recent discoveries might suggest otherwise, or at least raise intriguing questions. The most distant space probe, Voyager 1, has been traveling for about 47 years as of 2024 and still sends data to Earth, though its power is dwindling. And one day in 2021, scientists detected a strange, unexpected cosmic hum in the data. Although the probe had sent similar recordings before, the newly detected signal was quite different and more persistent than previous observations. Asterisk, for the first time in human history, we got an extended chance to listen to what interstellar space sounds like, or rather, to detect the electromagnetic waves and plasma oscillations that exist there. This signal was found more than 14 billion miles from Earth, in the space between stars where no human-made object had ventured before the Voyagers. Asterisk, it was a frequency that remained stable at about 3 kilohertz for nearly 3 years. Between 2017 and 2020, this became the most stable and longest-lasting hum ever discovered by Voyager 1 in interstellar space. Scientists could only detect and analyze it because the spacecraft had traveled so far from the sun's influence and into the relatively calm environment of interstellar space. Asterisk. But where did this mysterious sound come from? Most scientists believe this hum is the result of plasma waves traveling through the interstellar medium. Plasma is a state of matter, the fourth state beyond solid, liquid, and gas, where atoms are ionized, stripped of some electrons, creating a soup of charged particles. It's a kind of main building material from which almost all cosmic objects are made, and it permeates the space between stars. Asterisk, the shocking thing is that even after the probe moved another billion miles forward, deeper into interstellar space, this sound remained almost the same, maintaining its frequency and character. Such high consistency over such an enormous distance forced some scientists to wonder whether there might be an energy source we don't yet fully understand, some process in the interstellar medium that generates these waves continuously. Asterisk, but how is this possible when there's no sound in space at all? How can we talk about hearing anything? Well, it's true that sound waves, as we know them, vibrations of air molecules that our ears detect, dissipate very quickly in space's vacuum because there aren't enough particles for sound waves to propagate through. Even sounds from major cosmic events like black hole collisions or supernova explosions don't create sound waves that travel through space. Asterisk, but electromagnetic waves are different. These waves, which include radio waves, light, X-rays, and gamma rays, don't require a medium to travel through. They can cross the vacuum of space at the speed of light. And plasma waves, oscillations in the density and electromagnetic fields of plasma, can travel through the thin plasma that fills interstellar space. Asterisk, so how did Voyager 1 collect these faint signals and send this data to Earth? Well, the spacecraft was designed with 2 hypersensitive antennas extending from its body like long whiskers. These antennas, which are actually part of the plasma wave subsystem instrument, were built specifically to detect and record plasma variations in space, measuring the electric field fluctuations that occur as plasma waves pass by. Asterisk, despite using radio signals for communication, which travel at the speed of light, covering the enormous distance between Voyager and Earth takes more than 22 hours each way. The signal is so weak when it arrives at Earth that it requires the combined power of multiple giant radio telescopes in NASA's Deep Space Network to detect and decode it. Asterisk. The sad truth is that soon we won't receive any signals from Voyager 1 or its twin. According to scientists, the spacecraft's power is running out steadily. The radioisotope thermoelectric generators that have powered these spacecraft for nearly half a century are producing less and less electricity as their plutonium decays. That's why the probe's essential instruments will probably work for only another year or 2 at most. Perhaps into 2026, Asterisk Voyager has done far more than we expected, far exceeding its design life and original mission goals, and it might still surprise us with more life-changing discoveries in its remaining time. Though that time is growing short, engineers continue to carefully manage the declining power, making difficult decisions about which instruments to shut down and which to keep operating as long as possible. Asterisk, although the probe's latest discovery of the interstellar plasma hum is significant, NASA has discovered other strange sounds before that puzzled scientists and captured public imagination. In 2007, researchers found something strange unexpectedly while analyzing data from a few years earlier. What they revealed were FRBs, or fast radio bursts. Asterisk, these are among the most mysterious phenomena in astronomy. They're so fast that each burst lasts only about 1 millisecond, a thousandth of a second. In that brief instant, a fast radio burst releases as much energy as the sun emits in an entire day, an almost incomprehensible amount of power concentrated into a fraction of a second. From this discovery point, researchers started searching for other possible FRBs, and they found many more. Hundreds of these mysterious bursts have now been detected coming from various directions in the sky. Some FRBs occur once and are never seen again from that location, while others repeat, flashing multiple times from the same source. These radio bursts would sound something like rapid-fire clicks or pops if we could hear them. The more we learn about the universe, the more questions arise. Could these be attempts by intelligent alien civilizations to reach us? Perhaps powerful beacons or communications intended for someone else that we're accidentally intercepting? Maybe these signals weren't meant for our eyes and ears at all. Who knows? Most astrophysicists believe these FRBs originate from natural sources, perhaps from magnetars, which are neutron stars with incredibly powerful magnetic fields. A magnetar is probably the most extreme object that can exist in the universe. Without being a black hole, these are the cores of dead massive stars compressed to incredible density. A teaspoon of neutron star material would weigh 1 billion tons on Earth. When magnetars experience stark wakes, sudden cracking and shifting of their incredibly dense crust, they can release enormous bursts of energy that might manifest as fast radio bursts. Other theories suggest that FRBs might be caused by colliding neutron stars, collapsing massive stars, or even black holes consuming neutron stars. But some scientists have more exciting ideas. Professor Avi Loeb from Harvard and other researchers have proposed that these powerful signals could be misdirected alien transmissions. Their theory suggests that these might be leakage from enormous beaming systems, used by advanced civilizations to propel their light sail-driven cosmic ships across vast interstellar distances. In this scenario, an alien civilization might be using powerful lasers or radio transmitters to push spacecraft equipped with enormous light sails, using the pressure of light or radio waves to accelerate the craft to a significant fraction of light speed. If Earth happened to be in the path of one of these beams, we might detect it as a fast radio burst. The beam wouldn't be intended for us. We'd just be accidentally intercepting it. Both sides of this debate agree that these FRBs must come from unimaginably distant sources, billions of light years away from our galaxy, given the immense amounts of energy involved. And while our technologies are limited in observing such distant sources, it seems we've established quite a good grasp on our own solar system and its immediate neighborhood. Yet NASA sometimes finds eerie or unexplained sounds even within our planetary system. Mars, for instance, has provided its share of mysteries. We've been studying the red planet for quite some time, and NASA's Perseverance rover recently found something that caught public attention. The first real sounds of driving on Mars. But what's interesting about these sounds? Well, along with the expected sounds of metal wheels rolling across the rocky Martian surface, crunching over pebbles and sand, Perseverance captured some unknown sharp scratching sounds that appear intermittently in the recordings. These are actual recordings sent by Perseverance back to Earth, converted into audible sound for human ears. No one knows for certain what causes these mysterious scratching sounds. They don't match the expected sounds of wheels on rocks. Could they be caused by static electricity buildup and discharge in the extremely dry Martian environment? Could they be rocks caught in the wheel treads being expelled? Could they represent some interaction between the rover and the Martian soil that we don't fully understand? While NASA scientists work to find clues and explanation, this mystery remains unsolved and leaves room for imagination. It's a reminder that even in a place we've studied for decades with multiple rovers and orbiters, Mars still holds surprises and unexplained phenomena. Scientific and technological progress never stops. Looking forward to 2030 and beyond, there are plans for potential interstellar probe missions that could dwarf even the achievements of the Voyagers. Scientists say such a mission could be as revolutionary as the first moon landing was, representing humanity's serious commitment to reaching beyond our solar system in new ways. Just imagine the largest rocket ever built, perhaps powered by nuclear propulsion or even more exotic technologies, flying at the fastest speeds ever achieved. To go 10 times farther than Voyager 1 in a reasonable time frame would require speeds far exceeding anything we've accomplished so far. The expected lifespan for such a spacecraft would be at least 50 years, possibly longer, but given Voyager's success and today's advanced technologies, everyone hopes that future interstellar craft will last even longer. and travel even faster than seems possible today. Such a mission would be humanity's first truly significant step into the realm of stars, a commitment to interstellar exploration that goes beyond the happy accident of the Voyager's extended mission. The mission's main objective would be to study our entire solar system from outside, capturing an image of the whole solar system from a great distance similar to, but far exceeding the famous pale blue dot photograph. It would continue exploring interstellar space with instruments far more sophisticated than those aboard the Voyagers, studying the interaction between our heliosphere and the interstellar medium, investigating the structure of the local bubble, and perhaps even reaching toward nearby stars. Once such missions become reality, we'll get closer to defining our place in the infinite universe and solving mysteries of deep space that the Voyagers could only begin to address. We'll learn more about other stellar systems, perhaps detect planets around nearby stars, and maybe even find evidence of life elsewhere in the cosmos. In the history of spaceflight, only 5 spacecraft launched by humanity have achieved or will achieve escape velocity sufficient to leave our solar system entirely. The Voyagers are 2 of these spacecraft. The others are Pioneer 10 and 11, which preceded the Voyagers and are now also traveling through interstellar space. Though we lost contact with them years ago, and New Horizons, which flew past Pluto in 2015 and is now heading outward, though it won't reach the heliopause for many years yet, these spacecraft have discovered far more than anyone thought possible, and lasted much longer than anyone estimated. Yet despite their achievements, despite being humanity's first emissaries to interstellar space, many people have never heard of them. They don't get the recognition they deserve. That's why it's important to tell their stories, to remind people of these incredible machines and the humans who built and operate them. The complete story of the Voyagers is one of vision, perseverance, brilliant engineering, and remarkable luck. It's a story that deserves to be remembered and celebrated, a testament to what humanity can achieve when we set ambitious goals and commit to reaching them. These twin spacecraft, built with primitive technology by today's standards, have outlasted all expectations and continue teaching us about the cosmos nearly half a century after they left Earth. As we look toward the future and imagine new interstellar missions, we should remember the lessons of Voyager: build robustly, plan for contingencies, be willing to take calculated risks, and never underestimate what determined humans can accomplish. The Voyager legacy will inspire space exploration for generations to come, reminding us that the universe is there waiting to be explored, if only we have the courage and commitment to reach out and touch it. Thanks for watching. Do subscribe if you liked our video. Thank you.